Hi there, I'm John Neisted, Delaware Riverkeeper Network, registered landscape architect, and I'm in charge of the restoration program. So today I wanted to dig into infiltration in soils and just demystify a little bit of infiltration testing and soils testing. I'll do my best to demystify it, but that's a deeper subject, pun intended. So rain gardens are basically stormwater best management practices. And what I'm going to do right now is just give a quick overview of rain gardens, just to set up the conversation. Rain gardens are a best management practice such as bioswales and basin retrofits. And why? Reduce runoff volume, filter pollutants, recharge groundwater, reduce stormwater temperature impacts on streams, enhance evapotranspiration out of the plants, enhance aesthetics, and enhance habitat. Bioretention areas, rain gardens, are a water quality and quantity control practice using chemical, biological, and physical properties of plants, microbes, and soils for removal of pollutants from stormwater runoff. I really like that definition. So that's what a rain garden does. So here in our region, we have highly built up areas, and the runoff from those areas contains pollutants. And most storms are small storms, so by catching the first inch of runoff from pavements, you get most of the pollutants. So rain gardens are basically a water quality control system, and they do reduce volume a little bit. There's two basic types of rain gardens, one with an underdrain and one without. If the soils don't perk well, you use an underdrain, or if you really want to engineer it, some projects, like for a new construction, require a certain amount of a quick drain down within 2 days of the soil. So an engineer might choose to put an underdrain under it, but it adds a lot of cost, and I usually like to avoid that. The infiltration testing process, first step is background evaluation. Things like soil surveys and looking at existing conditions. There might be a sketch plan from an engineer or that you do of where you think your rain garden might go. Now, if it's in your own backyard, it's pretty obvious. You know, you have a low area, maybe you want to put the rain garden there or away from the house. So just some basic background investigation. And then for more serious engineering of rain gardens and bioretention areas, it's important to do a test pit, digging down about 72 to 90 inches. And I'll have a picture of what that looks like. So that's clearly with a backhoe. If you're doing a backyard rain garden, you really don't need to do this. It's a little bit more of observation, where if there are puddling areas in your backyard and they drain down within a couple of days, you've got a pretty good perk. So you don't have to go all the way down and do the major engineering. This is what the test pit observations when doing that. You look at soil horizons, soil texture, color patterns, depth to water table, like is there water down there? There's also an indication, which I'll show in a minute, of water table, how it affects soils. If you hit bedrock, clearly that's not a good place for a rain garden if it's shallow bedrock. And then just look at the rest of the features down in the pit. That's an example of a test pit. This is Meliora that we worked with on Sadler's Woods, which is a Van Sciver rain garden. So it's about 7 feet deep, 6-7 feet deep, and it's used to check out the soil. And then there's this shelf right here, which is done where you can do the infiltration testing. So this is a pretty, yes?
As a point of interest, is a copy of your PowerPoint available?
Yes, it'll be available on the website. And there is technical things here which I'll blow through a little bit. So the soil mixes, for instance. So that's you won't have to take all the notes, and then it'll be available by the video too. So this is what we'll focus on a little bit today. Is the actual infiltration testing, but it's a whole process. One thing one needs to do when looking down in these pits is to find out if there's any soil modeling showing some intermittent high water table. So when the water saturates the soil, it tends to be gray and does that type of modeling. So if you found say if we found that right here, which we did, we know that there is a little bit of water table coming up seasonally in this area. So it gives an indication. If you have a high water table, it's hard to get percolation. Now in an engineered facility, getting approvals, that's a big deal. But if it's your backyard, you have an intermittent high water table, it's not the most horrible thing to have a little extra water some years in your backyard in your own rain garden. My rain garden's like that. Some years it might fill up for a couple of days, but usually it just drains right down. This is the infiltration. That's called a double ring infiltrometer, and that's a pretty standard Pennsylvania test. And we'll talk about that a little bit more. It's important to do soil testing. I can't emphasize enough it. There's a whole transition now in the design field. I've got to make sure to do the soil testing at the beginning because it helps everything at the end. You can save thousands of dollars. If you do the soil test at the beginning, then you can figure out how to do the soil mix at the end. So a typical process is you get through it, you forget to do the soil test. You get to the end, you talk to the landscape architect, and they say, I really don't want to buy, all these hundreds of thousands of cubic yards of rain garden mix. Can you use the soil that's there? And they'll say, well, I don't know what's there. So do this testing at the beginning. Typically, what I test is the topsoil and then a little bit of the subsoil. So if we're going to dig down about 2 feet in this rain garden, then you know that soil there is available to mix into some new soil for the rain garden. Infiltration testing you want to do at the intended bottom of the garden soil. So say if you have a rain garden that is, say, 1 foot deep, where the ground goes down, so you're going to dig down about 1 foot, and then there might be, say, 1 foot of rain garden soil. So you want to go down 2 feet from the existing grade to do your infiltration test. The trick is to do it at the bottom of your new soil. So you got to dig down. Now, a lot of the videos you'll see of how to do an infiltration test informally, it's just like they just dig a hole right at the surface and do an infiltration test right there. And that often doesn't have real indication of what's going down 2 feet down where the real percolation is happening. So there are actually, there's an exact nomenclature. An infiltration test, infiltration is the rate going straight down. Percolation, and for the purposes of this presentation and Pennsylvania regulations, is percolation accounts for going straight down and sideways. So an infiltration test is actually what we want, what goes straight down, because a rain garden, got a big area, water's going down everywhere, very little's getting out the sides. So infiltration is important. Percolation, one can do a percolation test, but then there's some factors. It actually tells you too much, and I'll get into it about what a percolation test versus an infiltration test. But it measures the rate about 2 to 4 times too fast. I'll get into that in a minute. This is a double ring infiltrometer, and how it works is that you fill up both sides. And we have one of these. We'll play with them a little bit if we have enough time. We'll go outside and we'll just do a quick demonstration. Fill it up, saturate the soil, and then the outer ring stays filled up. And what's measured is the inner ring. So you keep adding water to the outer ring to keep it saturated, and the inner ring is where you measure. So if it goes down an inch in an hour, that's a good infiltration rate. Even a ½ inch in an hour is usable. So what happens is the water in the outer part of the ring saturates the soil. Similar to, think of a whole rain garden situation. There's water coming down everywhere, so what you measure is the very middle.
So the homeowner could dig his hole and saturate this hole first and then measure it. Is that a reasonable approximation?
No, that's a percolation test, and then you have to give the factor. So you have to reduce that percolation. I'll get to there in a second. You reduce that percolation rate by about 1/4 to about 1/2 to get to the infiltration rate. So this is more of a test you'll find online, Philadelphia Water Department. You dig a hole, and you just fill it up, saturate it, and then start again. So we can do this at our homes pretty easily. Dig a hole down. Philadelphia Water Department says to put a can in or a pipe in here. So New Jersey Native Plant Society, say if you fill this up, and I'll get to a second, this is the saturation point. So you let all that draw down. And then here, you fill it back up to about 1 inch from the surface, put a nail in, and then measure the rate of drop. Now you can see this water is going out the sides too, as well as out the bottom, which is fine for a dry well, but for a rain garden, that's not really applicable. So it comes up there are technical factors that the Pennsylvania Stormwater Manual gives to it. Very technically, you can look it up about the reduction factor, but it's anywhere from 2 to 4 times reduction factor. So this is just a quick and verbal description. Use a coffee can or pipe. This is the Philadelphia Water Department's Philly Watershed website. Dig soil to the depth of the bottom of the rain garden. I've adjusted this a little just to be a little more applicable. Drive can or pipe into the soil. Pour in water and let drain out once. Pour in again. If it drains 1 inch per hour, you're okay. So that's their instructions. What that probably relates to, and that they call it infiltration rate, it's really a percolation rate. It probably relates to about a 1/2 inch per hour infiltration rate. Now the New Jersey Rain Garden Manual, they don't say to use a pipe on the edges. So they can perk out the sides, and they use a different number. It says 1.5 inches per hour is a minimum rate. So it looks like they've already adjusted it for it going out the sides and out the bottom. And again, that probably translates to about 1/2 inch per hour infiltration rate. The Pennsylvania BMP manual has more specific instructions. It does allow this type of testing for rain gardens, but then you have to put all types of factors on it. You have to do it 8 times minimum, and each time you measure it, you have to have a 1/4 inch difference. And if you don't get a 1/4 inch difference, you have to do it again and again and again. It's very hard to get a quarter inch variance. And then it specifies reduction factors for the specific size of the hole and how deep the hole is. So that chart's online. And just because I'm sick of all the data, I want to look at some rain gardens. So here we go. There's a Peters Creek rain garden we put in. There's one in Garrett Hill. Morris Arboretum. Switchgrass, we talked about switchgrass in the last one, and this is a rain garden. They can look like all kinds of things. So let's get into soil. Bioretention soil depth. 18 inches is a good depth. 12 inches works. 36 inches works. Everything helps. The soil can be loam or sandy loam, capable of supporting plant growth. And this is out of the Pennsylvania manual. You can start with existing topsoil. So if your existing topsoil already has 5 to 10% clay, that's a good topsoil to use for a rain garden soil mix. And you can blend it in it, and it may have 5% organic matter by weight. That's just like a normal organic matter of our existing soils. pH 5.5 to 6.5 is best for pollutant removal. And then the manual says to add 20 to 30% composted organic matter by volume. So that's a good basic spec. Most people, if you have a reasonable soil, can just add compost, and it will work. But you just thought it'd be fun to look at the chart here. Okay, so it's a loam or sandy loam in this part of the soil chart. This is the clay, so follow the lines that way. This is silt, follow the lines that way. This is sand, follow the lines that way. So I just really like this. It says loam, 20% clay, 40% sand, 40% silt. This is the area that is useful for rain garden mix. But it's really nice to have the sand component in the 40 to 70% range. So A little bit more in here is a rain garden soil. Now, you can buy them. On this Garrett Hill project, the soil was so bad, it just was not worth it. So it was excavated out and brought in a new mix. That's very expensive. And I usually like to avoid it. And then there's the shipping costs and where you dump it. I'll do another recipe here if you're going to just make it, or sometimes you buy it from a place that makes it. 50 to 60% sand, 20 to 30% topsoil with a low clay content, and 20 to 30% leaf compost. And that's from Prince George's County. They're leaders in bioretention techniques. They're a good resource. And they say for a residential rain garden, sandy loam, loamy sand, and loam soils are usually okay. The soil test will tell you what you have. This is another one I found online, a little bit different. This is the Low Impact Development Center. So they say 15% by volume double shredded hardwood mulch. So that was an unusual one compared to a lot of other standards. 50% wash sharp sand, that's about right. Topsoil, yeah, that's okay. 10% maximum clay, and 5% by volume peat moss. So I put this up as you can't always follow everything you find online. I generally wouldn't use hardwood mulch, double shredded. It tends to be shipped down from Canada. Try to find a local composted wood chip. What the wood chips or the hardwood mulch do is they break down slower. So it's similar to a green roof soil mix that has a little bit larger material. It breaks down slower, so it gives a long-term organic matter input. So I haven't done this, but I see the logic in it. 50% volume wash sharp sand. That's good. It's also called concrete sand. Just make sure it's not from limestone, which changes the pH. Now, when it says peat moss is pretty unsustainable. It takes millennia to grow. So I would never use peat moss on a project. It changes the pH too. Not bad. It lowers it a little. But try to use local compost.
You can buy leaf compost from certain places like in Riverkeeper Township.
That's right.
And it's actually a little less expensive than mulch. I think
Yeah,
it's about $30 a yard, $25 to $30 a yard.
Yeah, and that's perfect.
But it comes from a community leaf fill, okay, in other words. And so one wonders about what else might be in there next with it.
Yeah, what I like, and it's in another slide, is I like to get it directly from the leaf crew of the town. If they take down a tree, in the summer, it comes with leaves and it comes with wood chips. And then you stockpile it someplace and then use that in the soil mix. So I like to know where it came from, because usually the tree crews aren't taking down invasive plants. And none of the street trees that I know of, almost none of them resprout from little chips. So it's more like the ailanthus that would resprout, and they tend to not be street trees, except, well, Philadelphia would have some. Compost is an important item, and it's a little bit of a mystery, so I just thought I'd show you. This is a technical spec for compost. It does include in here sewage sludge, so you can just delete this definition. This is used in a soil mix when one might be buying one. So as a landscape architect, this is a type of description we would use for compost. I won't bore you by reading it. It needs to be weed-free. I've seen some soil mixes come in that are full of weeds. So it's good to know the resource and ask for the references. Good landscapers will know who have the weed-free compost, because if they buy it from somebody who has a lot of weeds and they all come up, it's a pain in the butt. So they like to buy from weed-free suppliers. And how they do that, it might be what they blend, or if they compost it very well, it raises the heat and kills weed seeds. So the best thing to do is say reasonably weed-free. It's really hard to get it perfectly weed-free if it's an organic type operation. Use a local source. Use mature compost, so that as it's breaking down, it's giving off gases, oxygen and ammonia, And then the other way that it's tested is through seedling tests. So these are two ways to specify compost as mature. Composted local leaves are perfect, like we're talking about in tree leaf trimmings. Just quickly, I'll just talk about sizing the square feet of the rain garden because it is affected by the soils. If you have clay soils, more clay soils, the rain garden has to be bigger. So what you do is you figure out, okay, you've got this much roof, how big should the rain garden be? So if the roof was 1,000 square feet, the rain garden should be 200 to 300 square feet. So 20 to 30% of the drainage area. If it's clay soils in your rain garden in the backyard, it ought to be about 60%, about half of the size of the roof, because it takes a lot longer. These are just ballpark figures. They help in planning. If you improve the soil drainage and the soil, or put in an under drain, then the rain garden generally should be about 20 to 30% of what's input. So that's my little rain garden in the backyard. And I took this tree home in a paper cup from one seminar once. It's a river birch. Just quickly, my home, asphalt, rain garden over there. I did put some of the downspout into a pipe. I use it to water the garden through perforations, and then it overflows into the rain garden. It also takes water from the asphalt and from the landscape. So it's just a nice system. That perforated pipe also happens to provide aeration for the garden too. So it's just a nice system. This is one of the Delaware Riverkeeper network. It was engineered by Melior Design and designed by Delaware Riverkeeper Network and Jonathan Alderson Landscape Architects. And I did show this last year, but I'm just going to get into the soils parts. We did soil testing. The rain garden wraps around the school. So we did soil testing and infiltration testing in 2 locations. And it was very interesting. The 2 locations ended up being very different. One had a lot of clay and one had a lot of sand. So the topsoil was sandy loam generally everywhere. The critical thing to remember is clay. You want to be about 10% maximum. If you take one thing out of this seminar, 10% maximum clay for the soils, and you're golden. The pit east of the school had 23% on the clay, and the pit north of the school had clay down at 8%. And then we did do infiltration testing, so you can see the 23% had a ½ inch per hour infiltration rate, and the one that had clay of 8% had 1.44 inches per hour. So we adjusted the design on this. Just quickly, we took some of the sandy soil from the back, and put it in the front in a trench, and we took some of the clay soil that we had to excavate anyway out of the front and used it to make the berm in the back. So on this project, so here is some of the rain gardens, then it wraps around the school right here. So this is the area that had a little more clay, and this is when it was just scooped out, not planted yet.
Is this project written up somewhere so that one can see what?
Well, that's a good question. I should do that, right, Tracy?
Yeah, absolutely.
Yeah, I'll do it as a fact sheet online. We'll get that up. We did present this also at the Villanova Stormwater Conference to the engineers there. So it's been published in videotape, but you're right, it should be online so you can just click on it and learn.
Well, it's on videotape though at Villanova.
That's a good question. It's on videotape from last year here, actually.
Okay.
Yeah, so it's on that one. I went to it pretty detailed.
Are those the clay soils making up your berms on the side, and were they placed by
Oh,
that?
yeah. So this one here, for the sake of time, I actually deleted the existing conditions. This was flat lawn, so this was dug out.
That's your shallow, right?
Yeah, so we dug that out, and we kept these shallow in this area, just because of the clay soils we were worried about ponding. And we took that clay soil, and then for the rain garden down further, down further, we built up the berms at the end. So that wrapped around the building. So now I'm going to go back here. In general, I think it's just very important to include compost. Even if the soil didn't need it, it's important to do compost if just to get the top of the rain garden soil dug up a little. So you just heard another presentation about the compaction from the landscaper while they were building the rain garden. Well, if you say to mix in compost at a certain ratio into the top 6 inches, then the last thing that contractor will do, if you keep an eye on them, is mix in the compost, and then they're done. So they mix in the compost, backing out, and then you have a nice friable soil top that allows infiltration into that soil.
Mixing it in by a big rototiller?
Well, yes, people use rototillers. On this, they use something called a soil conditioner. I should have a picture of that. But they had a machine that had a cylinder about this big and it had things sticking out of it, and it would actually till the soil. And they use that for a couple of things. They use that to rip up the existing grass too. So that's what they chose to have on here. It was a light machine. So here it is, mixing it in. You can see this is the unblended soil here, and that has the compost blended in. So we're backing out. Oops. Yeah, backing out. And this is just a picture of that same area finished about a year later. There's a lot of more I could go into this. I'm thinking that we should get outside and do a little infiltration test, but before we do that, any questions? Yes.
Have you worked with any mushroom compost?
Yeah, mushroom compost has certain things in it that landscape architects don't like. I use it in my own backyard just because I live in South. No, I'm sorry, yes, it was mushroom compost, and it came through Magnolia Gardens. It was a little weird. I overwatered the lawn because I accidentally left the water on when and I got mushrooms crazy. It was, it was bad, and it stunk. Yeah, so it's not really the best, but.
Does that affect the soil? Is it the salt content? Or?
Yeah, that's what it is. And so it's a local recycled material. That's a plus, but it does have some factors in it that are worth caution.
What time element is connected with mature compost?
6 months to a year, but like for me, when I pile my leaves in the backyard and I don't have enough grass clippings, that doesn't do anything for 6 months. So if it's done right, with the right ingredients, and there's all kinds of online. Who does composting and just can answer that question? 6 months, a year?
You got to aerate it. You got to aerate it.
Yeah, it has to be aerated. Yep.
I somehow thought it was more than a year, to be honest.
It could be more than a year if it's like coarse material and doesn't have enough nitrogen, but if it's aerated, and some people have the composters that are really aerated, and if you start with all like coffee grounds and things like that, then it gets quick. Yeah.
Are rain gardens that self-sustaining? Because if they have a high sand content, then eventually the organic matter is going to decompose. Can they restore themselves?
Yeah, the organic matter, the plants only need about 5% organic matter. So when you hear of like the high volumes put into soils, it does a couple things. It fluffs them up, and then when that degrades, it's going to leave a little bit of pores. So I think it's a really good thing. The cation exchange capacity of the clay is very important. So the compost has cation exchange capacity, which allows nutrients to be held and then let go. So clay has great, that's why it's very important not to have all sand in your rain garden. It's important to have the soil with some clay. Because if it's just sand and compost, you're right, that compost is going to just degrade, and then the water will filter through too fast. So the plants, it's totally sustainable just by having about 5% clay in there.
And then every year, just the plant's kind of dying and regrowing will
That's it.
sustain itself?
That's it, yeah.
So I've read that you have to be careful if you're mixing clay into sand. You can reach a bulk density at some mixture where the clay actually starts clogging up the pores and so you can get something that roots have a very difficult time to grow
Yeah.
into. So how do you know that you will avoid that kind of a mix?
I'm not that incredible an expert of doing the actual mixing in the plant, but from practical experience, I haven't had a problem blending it. But that's a good question for a professional blender. So, sorry, I don't know the answer exactly. Yes.
We did a stormwater berm, which is kind of like an expanded rain garden, I guess, but, the water sits behind it, goes through the berm and gets water quality benefits. And
Yeah, that's
what they
good.
did was put a lot of wood chip in.
Yeah.
And then microorganisms that work on the wood chips create micropores.
Yeah.
And keeps it open for
Yeah.
30 years.
Joe Berg?
Yeah.
Yeah, those are great presentations. Joe Berg from Biohabitats did presentations the last 2 years. But if you can look up online, and they call it a few things like regenerative design. That's a great technique.
Maybe a little wood chips in there would be good?
Yeah, down in the soil. Yeah, and in that one, the water was passing through it.
Right.
So yeah, given that design,
All the silt and
Yeah.
stuff coming through over time,
Yeah.
it's going to clog it up, and you've got these little microorganisms.
that's it. So I think wood chips do make sense down in the soil.
Is that Berg or Berg?
BERG.
Okay.
He's here today.
Biohabitats.
Yeah.
Got that.
So they're good at that. And so we're also spearheading some projects that use that same technique. Yes.
My question has always been that if you dig a pit and put this enriched soil in there, but the pit is surrounded by compacted soil or soil that's not so good,
Yeah.
and then you put these plants in here,
Yeah.
and they decide, I'm not going to go out in that bad soil, I'm going to stay in this enriched soil.
Right.
Do these eventually become basically a pot-bound planter in the middle of your yard? I mean, I'm talking like 10 years and 15 years from now.
If it's surrounded by the clay soils, one would be required to put an underdrain in to get the perk through.
Right.
Because one mistake, and we've all seen it, is someone puts in a rain garden, you read someplace it goes in the low place of your yard, it's surrounded by clay, and it never drains. So it's just ugly. But a real rain garden that functions will allow the percolation. So there's air, and there's usually a little bit of width in it, and I've never seen them become pot bound. It's just for instance here, this is a natural meadow, and so that's basically using natural systems and native landscape type systems and installing them and letting nature do the work. Now, if it was say a curbside rain garden and it wasn't properly underdrained, perhaps that could get pot bound. But all that would do would just limit perhaps the height of the plants, and they would self-select, so the more aggressive ones would take over. And the grasses are a little more aggressive, so they'll tend to take over and have less wildflowers. It's a good question. I haven't experienced it becoming root
I mean,
bound.
have any of these been in existence for 15 years?
Oh, yeah,
Really?
yeah, because before the BMPs became really popular, for instance, Andrew Pogan Associates, I worked there for 15 years, so that's going back 30, 40 years for rain gardens being installed and functioning. What's really nice is that that type of cutting-edge ecological design is now the law, so it's really nice to see that. Yes.
I'm from Riverkeeper Watershed Conservancy,
Yes.
and we are a land clay and shale, and we have a few rain gardens on our property where we completely, used a rain garden mix, completely excavated the existing soil, and we haven't had any trouble with the sides. I mean, roots do go into the sides, they might not like it as much, but if you scrape up the sides a little bit, just like when we're planting trees in the clay soil, it helps to scrape the sides a little bit, give them grooves to latch onto. And don't you want kind of a network of roots underneath
Ideally,
the
you do.
soil? Does that
Ideally,
help?
you're right though. There are boundaries where plants sometimes roots just say, I don't like it over there, and they won't go. So if you tried to put a tree in a little rain garden, that would be a little nuts. The rain garden's, say, a foot deep. It might fill up with 6 inches of water, and then you might have a foot of rain garden soil, maybe 2 feet. So the trick is the percolation is below that, because your rain garden soil should be designed to have a low clay, enough sand in it, that it'll go through that. So what you care about is what's under that. So let's assume this is down a couple of feet. This needs to go in about an inch, 2 inches, they say too. Sometimes these are 6 inches high, but this one's only 4 inches high. So if you had a 6-inch high one, you could go in 2 inches and have about 4 inches left over for water. It's fun to do. You have to bang it in. That's what this is for. There's your sledgehammer. Stand on this side because we have a camera there. And just bang that down. Hold your ears. Yep. Let me get all the way around. Good. That's good. Probably a little bit more. Trick is to be level. A few clicks. Pretty much, let's assume it's level. I have some first thing you do for about an hour is fill it up and soak it.
Center and edge?
Yes. So we'll assume we've pre-soaked it. You see here it says testing procedure pre-soaked. You can read there, during the pre-soak period, there's a protocol for how fast it drains, and then it determines the intervals of how often you test. The interval is usually every half hour of how often you measure. But it might be as little as 10 minutes if it soaks through fast on the pre-test. So let's assume now we finished the pre-test and we're doing every 30 minutes for the test. So what we do is we refill it. So we refill it. And we're going to measure it. We'll start the timer, keep a log. And what's measured is this right here. Take your trusty ruler, and after a half an hour, measure how far down it went. Never refill this area, but if this happens to all drain out on the outside, refill that. Now when you're pouring it in, it's nice to break it up a little bit, break up the water so it doesn't mess up the soil underneath too much. So try to break up the flow a little bit. So this is going straight down. This is helping it go straight down, saturating the soil. So do it multiple times according to procedures, 8 consecutive readings. So that's an all-day event. And you get pretty bored. You can sometimes do 2 of these at the same time. Bring a good lunch, a whole bit.
And as it goes down, then it's going to slow it down each time, isn't it?
The trick is to get a steady rate. So if you're finding it slow down, you can't actually use those readings that went fast. You have to use 8 consecutive readings of a 1/4 inch or less. Now that's to meet Pennsylvania guidelines.
Quarter inch per unit time.
1/4 inch per unit time, that's right.
So it's a variance. You need
That's
to
it.
you need to keep your variance
That's
very
it.
close.
Now for me, if I get 4 in a row and I'm doing a rain garden, that's a voluntary rain garden, which many are, as we're doing volunteer work and retrofits. I do 4 in a row, but the engineers and submissions have to do 8 in a row. And that could take a while. And that's it. It's really that simple. I just wanted to demystify it. It's fun to watch.